Now we will discuss Milne Thomson method to find an analytic function given either the real part or the imaginary part. Okay, as usual, how do we do it? We had seen how to construct an analytic function using the exact differential method. Now we know that f dash of z is dou u by dou x plus I dou v by dou x. Okay, so we will divide this into two categories. Suppose if u is known, I know u, I have to find the function f of z, but of course here the basic condition is that f of z has to be analytic. So now what happens here is that I have this f dash of z which will be dou u by dou x plus I dou v by dou x. I'll replace this dou v by dou x in terms of partial derivative of u either with respect to x or y. So what I will do is I will use the CR equations. Dou u by dou y is equal to minus dou v by dou x. So I'll have f dash of z is equal to dou u by dou x minus I dou u by dou y. Now what I do is I will find f dash of z which is dou u by dou x minus I dou u by dou y by restricting it to z comma 0. So once when I substitute x is equal to z and y is equal to 0, f dash of z will be a function of z. So from that I will have f of z is equal to integral of dou u by dou x minus I dou u by dou y at z comma 0 dz. So what you have to do is you have to find the partial derivatives dou u by dou x, dou u by dou y, substitute it in the formula f dash of z is equal to dou u by dou x minus I dou v by dou x. Put x is equal to z, y is equal to 0, integrate, you will have the function f of z. Now if I know that v is known, if we are given with v, how do we do it? The same process. F dash of z is equal to dou u by dou x plus I dou v by dou x. I have to express f dash of z entirely in terms of partial derivatives of v. So what I will do is dou u by dou x is equal to dou v by dou y by CR equations. I will have dou v by dou y plus I dou v by dou x. Okay. So now what happens here is that f dash of z will be dou v by dou y plus I dou v by dou x. As usual, replace x with z, y with 0, and from that you can calculate f of z is equal to integral of dou v by dou y plus I dou v by dou x at z comma 0 dz. So this will be the formula to evaluate the analytic function when v is given, and similarly this will be the formula for the value of f of z when you are given with u. So now what we do is, instead of using the exactness, we replace x with z and y with 0. So f dash of z will entirely be a function of z, and from that you can integrate it with respect to z to get the required solution. So as an example here, we are given with f of z is equal to u plus iv is an analytic function. You know, you have to take this. The basic assumption is that it has to be an analytic function. Okay. So now what I do is, given u is equal to, you are given a function like this, u is equal to e power x into x cos y minus y sin y, x cos y minus y sin y. Okay, what do we have to do? We have to find f of z, okay, which is equal to u plus iv. Okay. In the previous case, what did we do? We calculated v and then we wrote u plus iv. But whereas when you use the Milne Thomson method, you will directly get the function f of z. So how do we do it? Solution. You know, u is equal to e power x into x cos y minus y sin y. Okay. So first what I will do is I will separate this into two parts. Now what will be dou u by dou x? Dou u by dou x, here these two are functions of x. So I will have e power x into, I will differentiate this, I will have cos y. Okay. Plus x cos y minus y sin y. Differential of e power x will be e power x. So at z comma 0, dou u by dou x will be e power z, cos 0 will be 1, plus I will have z e power z. Z cos 0 is 1, sin 0 will be 0. So this will be z plus 1 into e power z. And similarly, what will be dou u by dou y? Dou u by dou y will be e power x. I have to differentiate cos y. I will have minus sin y minus of, here I have y sin y, so I have to use the product rule, y cos y plus sin y. Okay. So now when I substitute at z comma 0, okay, dou u by dou y will be 0 because sin 0 is 0. Here I have y which will be 0. Similarly, sin 0 will be 0. So the value of dou u by dou y will be 0. So now what I have to do is, I write the formula f dash of z is equal to dou u by dou x minus I dou u by dou y at z comma 0. This will be your formula, Milne's formula. Okay, and this was obtained in the previous slide. So this will be z plus 1 e power z. So you can see that f dash of z is now entirely a function of z. So from that, f of z will be integral of z plus 1 e power z dz. So what I will do is, I will use integration by parts. This will be z plus 1 into e power z uv minus u dash. Differential of z plus 1 will be 1, and integral of e power z will again be e power z. This turns out to be z e power z some plus constant c. Therefore, here your function f of z will be z e power z plus c. C can be a complex constant, and when you just compare the real parts, the real part will be e power x into x cos y minus y sin y. Suppose if you want to know the imaginary part, you have to separate this function z e power z into real and imaginary parts and get the imaginary part. This completes this particular